Hi, I'm John Connolly at the Dolan DNA Learning Centre of Cold Spring Harbor Laboratory. The science community is enjoying its annual week in the spotlight as the first of the 2009 Nobel Prizes was announced today. Elizabeth Blackburn, Carl Greider and Jack Szostak will share the Nobel Prize for Physiology or Medicine for their work with telomeres and telomerase. I spoke this morning with Dr. Bruce Dillman, a former colleague of Greider's at Cold Spring Harbor Laboratory, where he explained the significance of the discovery.
Telomeres are the ends of chromosomes. They were actually found in an interesting way. Herman Muller and Barbara McClintock, who worked at Cold Spring Harbor Laboratory for 50 years, they found that when chromosomes break, the ends of the breaks are very unstable and they tend to fuse together. But of course, when you look at chromosomes in a cell, specifically when they're spread on a microscope slide, the ends of the chromosomes, the natural ends, are not fused together, so they were somehow protected. And these were called telomeres, and their nature remained elusive for many years. Subsequently, Carol Greider, when she was a graduate student in Elizabeth Blackburn's laboratory at the University of California at Berkeley, found an enzyme that synthesizes short fragments of DNA that add DNA onto the ends of chromosomes. These ends turned out to be repeats of sequences, and the repeated sequences had been found by Elizabeth Blackburn and Jack Szostak before in an organism called Tetrahymena and a yeast, Baker's yeast, Saccharomyces cerevisiae. So the discovery of the enzyme telomerase really answered the question of, how these ends of chromosomes are protected. It turns out that this repeated sequence binds many proteins that protects the DNA from degradation. It is thought that you need telomerase, the protection of the ends of chromosomes, to ensure that cells don't age because of the DNA damage that's occurring there. The other thing that has also been discovered since the original discovery of telomerase is that cancer cells often mess up this process and have very unstable chromosome ends. So it was the Nobel Prize for Medicine and Physiology because I think it has important implications for cancer and aging, but most importantly, it's a very important basic discovery for understanding how chromosomes are stable and are copied from one cell generation to the next.
Blackburn, Greider and Szostak are currently celebrating their prize at their respective institutions: the University of California, San Francisco, Johns Hopkins University School of Medicine, and the Harvard Medical School.